All right, so picking up with this next example, number 3, as you can see, the directions say that we want to identify the following conics and put into standard form. So the first thing that we're going to do in reading through, see that we have negative 5x squared plus 7y plus 10x plus 8 equals 0. So given that equation, I know right now, without actually doing any math, I know that we have a parabola. So our 4 choices for a conic section are parabola, circle, hyperbola, and ellipse. So remembering, of course, that the reason I know that this is a parabola right off the bat is that there's only one squared term. If there was an x squared and a y squared, then it wouldn't be a parabola. It's just that simple. If it were a circle, there would be an x squared term and a y squared term that specifically have the same coefficient. If it were a hyperbola, then the x squared term and the y squared term would have different signs, meaning one's positive, one's negative. And if it's an ellipse, there's an x squared term and a y squared term where they are containing the same sign. So we don't have to worry about those other ones. We already know that this is a parabola, but the next piece of information is that we need to put this into standard form. So we have 2 options when it comes to the standard form of a parabola. We know that we have either the horizontal or the vertical. So, with that being said, we know that this is actually going to be a vertical parabola. And no, it's not that I'm writing this down because I'm thinking that we're going to have to draw a sketch or anything like that. This is now going to give us our target. Again, we know that, again, this is vertical because we have an x squared term. If we simply had a y squared term, then it would have been horizontal. If you're getting a little confused by that, just think about the parent function, f of x is equal to x squared. And hopefully what comes to mind immediately is that we're looking something like this. Again, we have a vertical parabola when the x term is squared. So matching that here, but with the x squared term. But what we're really wanting to focus on is what that vertical parabola is going to look like. So template being x minus h squared is equal to 4p times y minus k. So again, if we know that this is what we're trying to turn this into, it gives us a good idea as far as what has to happen. So hopefully we're thinking that we need to complete the square, but before we do any of that, I have to rewrite this equation to where I've grouped the x terms and the y terms together. So I'm going to rewrite this as negative 5x squared plus 10x plus 7y, and I'm going to move that 8 over to the other side. So equals negative 8. Before I complete the square, I'm going to have to get a positive 1 for the lead coefficient on that x squared term. Excuse me. So that means that I have to factor out my negative 5, which is going to leave me with x squared minus 2x. And you know what? Now's as good a time as any. We may as well move that 7y over as well. So I'm going to subtract the 7y over. So negative 7y minus 8. All right, so in completing the square, again, it's all about the b value. So here b is this negative 2. So what we're going to do, remembering that we're going to take b divided by 2 and square it. That's what goes in this space here. So for this particular problem, negative 2 divided by 2 is negative 1. Squared is going to be positive 1. So whatever we do on the left side, we have to match and do it on the right side. So it looks like we're adding positive 1 on the left side, so we should think about adding positive 1 on the right side. But if we do that, it is a mistake because I'm not actually adding positive 1 on the right side. I'm actually adding negative 5 on the right side because of this scalar we have to consider. So if I'm adding negative 5 to the left, I have to add negative 5 to the right side. So whole reason for this is I have to turn this set of parentheses into a binomial squared. So I have negative 5 times the quantity of x minus 1 squared is equal to, now on the right side, I have negative 7y minus 13. So my left side isn't perfect yet, but not a whole lot that we can do currently. Again, to make it perfect, we're just going to have to get rid of that negative 5 as the scalar. But before doing that, we need to make this set of parentheses, the y minus k, we have to make sure that we have in here a positive 1 for that least coefficient of y. So if we're to rewrite on my left side, we have negative 5 times quantity x minus 1 squared is equal to, I have to factor out the negative 7. So in doing that, I know this seems like an odd step. If I factor out the negative 7, that's going to leave me with y plus 13/7. So I know that some of us are thinking, geez, that's a messed up or weird looking k value of negative 13/7. But remember, we don't have to graph this. We don't have to sketch this. We just have to put this in the proper form. So our final move is going to be to get rid of this -5 by dividing both sides by -5. So on the left side, we have exactly what we want as x minus 1 squared is equal to, and on the right side, what we really have is -7 over -5 times the quantity y plus 13/7. I can only hope that we're recognizing that -7 over -5 is going to turn out to be positive 7/5, and this would be our final answer. So again, we do not have to graph this. We do not have to identify P. We don't even have to identify H and K. What we simply had to do is put this into standard form. All right, so on to the next problem. Again, similar in terms of the amount of stuff that we're going to be doing. This time we want to graph the following conics, identify each piece of the graph. So again, here specifically we're talking about center, vertices, foci, things like that. So the first thing that we want to identify here is the type of conic section that we have. So in number 4, my giveaway is the sign in the interior. First off, we know it's not a parabola because we can see that we have x squared and y squared. So not a parabola. Also, we know it's not going to be a circle because number 1, I'm not adding in between, and number 2, I don't have the same denominators. Number 3, for similar reasons, it's not going to be an ellipse because I'm not adding in between. Last thing that we have in terms of options, because of this being a subtraction problem, we know that we're going to have a hyperbola. So hyperbola is great to know, but we also need to identify whether or not this is going to be horizontal or vertical. And we're going to say that this is actually horizontal, and the reason is because the x squared term comes first. Okay, it is positive. X is positive here, y is negative here. So for that, x squared is, I should say, is positive, y squared is negative. So for that reason, if the x term came first, the y term came second, then we know that we're going to have a horizontal hyperbola. Okay, so we have that out of the way, but all that really leads us to is to consider, kind of like what we did on the previous slide, what our template's going to look like. So what we're really looking at here is x minus h squared over, remember, on a hyperbola, a squared is always going to be your first denominator. We don't care if a is bigger than b or b is bigger than, that doesn't matter. With an ellipse, absolutely matters, but here, with the hyperbola, it does not. So continuing on, we're going to subtract quantity y minus k squared, that's over b squared, and that's got to be equal to 1. So again, this is my target. So if that is the target, we can now identify h, k, a, b, and c. So h is simply the amount that's being subtracted from the x term. So it looks like h is 3. K is the amount that's being subtracted from the y term, so that must be -4. If a squared is equal to 16, that tells us that a is 4. If b squared is equal to 25, that means that b is 5. And in order to obtain c, we've got to remember a little formula. So c squared is equal to a squared plus b squared. It's only a squared plus b squared because we said this was a hyperbola. If it were an ellipse, it would be a squared minus b squared. So with that in mind, we're going to plug in, say that c squared is equal to a squared, 16 plus b squared is 25. So in adding those together, c squared is going to be equal to 41. Finding the square root of both sides, and we can now confidently say that c is root 41. Okay, so with that information, we have h, k, a, b, and c. Next move is to identify the center point, crucial to our success of the graph. Luckily, the center point is relatively easy to work with here. It's just going to be hk, so we're going to land on 3, -4 for our center point. So in plotting 3, -4, we're going to just count over 1, 2, 3, down 1, 2, 3, 4. Got it. Okay, so we have the center point. Next, it does ask us to identify the vertices. So the vertices, they're going to be located 8 units away from the center. But this is where it became absolutely essential that we correctly identify this as horizontal. If we accidentally thought that this was vertical, then I would find myself putting the vertices 4 units away above and below the center point, but that would be incorrect. Again, we know that if it's horizontal, I'm going to count to the left 4 units and put my first vertex. I'm going to count to the right 4 units to put my second vertex. So in identifying where those points are located, excuse me, identifying where those points are located, it looks like -1, -4, and count boxes here, 7, -4 as well. But now we have our center, we have our vertices. If next we're thinking about the foci, if we were to consider the foci, go ahead. Yeah, go ahead. It's fine. If we were to consider the foci being on this same line, the same axis, we could put this all together. So the way that we would want to consider this working is that the center point was at 3, -4. If I'm moving to the left, root 41, so we just have to think about root 41 is going to be between root 36 and root 49, so between 6 and 7. So that means I'm going to count to the left, I don't know, between 6 and 7 units, like 6.5, whatever. So over 6, something like this, which is great, but that's very much an approximation of where we're at. Very much an approximation. So in reality, what we're doing is that from the center point of 3, -4, if I went to the left, root 41, it's like subtracting root 41 from my x term. So again, if my center point was at 3, -4, if I went to the right, root 41, we're going to add root 41. But those are my foci. We've sketched them, but more importantly, we have identified where they are located. Let's see. We've got the center point, the vertices, the foci. Next, I know it didn't say, but on your test Monday, you're going to be asked to figure out where the asymptotes are located. So this is kind of, I don't know, tough for some people. I understand that, but what we're looking for, again, y minus k is equal to plus or minus the slope. I'm just going to write it this way, times x minus h. The reason I have to say the slope is because it depends on which type of hyperbola we have. If we have a horizontal, it's going to be one thing. If we have vertical, it's going to be something else. But what it really comes down to is that your slope is going to be plus or minus a. I definitely drew that backwards. Your slope is going to be equal to plus or minus a over b, or it's going to be equal to plus or minus b over a. So depending on what we have, that's going to lead to our understanding. So the way that I would encourage you to think of it the same way that we did in class is that we know that this measurement right here was A. Remember that slope is simply the rise over the run. So if you know that your run is A, it looks like in a horizontal that we're really talking about our slope as being plus or minus B over A. Now, if we simply had a vertical hyperbola, then if you think about it, A would be the certain number of units above and below the center point. So that would literally change everything. So for this problem, as we're continuing on here, just to fill in some of this stuff, we're going to say that my equation is going to be y minus k, which is -4. So y plus 4 is equal to plus 4 minus my slope is b over a, so 5 over 4 times the quantity of x minus h, which is 3. So here are my asymptotes. Next is going to be the art, I suppose, of sketching these in. So we've claimed that my slope is going to be positive and negative 5/4. So from the center point, I'm going to go up 5, 1, 2, 3, 4, 5, over 4. And I'm going to go down 5, 1, 2, 3, 4, 5, over 4. And this is going to be, hopefully your line is a lot straighter, but that's going to be my first asymptote. In the negative direction, I'm going to go down 1, 2, 3, 4, 5, over 1, 2, 3, 4, up 5, left 4, and that's going to be my other asymptote. Last step is going to be to make the sketch from here, and we've done basically everything that we need other than just finalize this thing. So I know that I have to draw the sketch so that it goes through the vertices, does not touch the asymptotes. So again, roughly sketched in, it's going to look something like that. All right, so guys, our next problem that we want to dive into here is the polar graph. I'm going to upload this portion of the podcast, and then we'll finish up on the next one.